Assalamualaikum and very good day. Welcome to video lecture Fluid in Motion part 2. In this video, I will teach you on an important part of fluid mechanics problem, i.e. control volume. But before we proceed, in the video part 1, I've explained to you on the Eulerian, where the flow domain or control volume is used in describing fluid in motion. We do not have to keep track of the position and velocity of a mass of fluid particle. Instead, we define field of variable such as the pressure field, the velocity field at any location and instant in time. Before we go in details, let me explain a bit more on the control volume. So, there are three important regions that are always present in the environment. The first one is the system, where the region chosen for study. The second one is the mass or region outside the system. We call it as surroundings. And lastly, the boundary, where the boundary could be the real boundary like surface, solid surface, or imaginary surface that separates the system and the surrounding. The boundary can be fixed or imaginary. Yep. For example, this bicycle pump. We are interested to know what happened to the compressed air in this part. So what we can do, we can precisely draw a diagram of this part, and then we draw exactly like this, like free body diagram. And then we do have firstly the boundary here, and then we do have the region that we want to know what is the value of the compressed air. We call it as system. And then we do have the outside of the system and the boundary we call surrounding. If you look carefully for the boundary, they have actually fixed boundary and moving boundary. What it meant by fixed boundary? Fixed boundary is something that doesn't move at all, or don't have anything that can allow the mass to get inside and to get outside. Another boundary is the moving boundary. The moving boundary here can be moved up and down. As we know, for the pump, we have to move the handle upward and downward so that the gap or the air in the system is compressed. The real boundary is represented by the bold line, the blue bold line. The imaginary boundary is represented by the dot line around it. The region that we are interested in can be divided into two: closed system and open system. Closed system consists of a fixed amount of mass, and no mass can cross its boundary. You can imagine a water in bottle, and then the bottle closely tied the lid. The bottle just stay there. Alright, you move the bottle, bend to the right, bend to the left. The mass of the water in the bottle remain the same. However, mass cannot cross, or mass is fixed. However, volume might be changed. For example, in this diagram, we do have piston cylinder. The piston definitely can move up and down, and it is a moving boundary, right? And then we do have fixed boundary, and then this is our system. You can see mass of the gas is 2 kg with the volume of 1 meter cube. How can we explain the control mass and the control system? When we heat up this piston cylinder, you know what will happen. The piston will go up, right? Whenever piston go up and then reach at this point, you will see the mass of this gas still the same, 2 kg. However, the volume is already changed increased to 1.5 meter cube from 1 meter cube previously. The mass still 2 kilograms. Another system that are famously used in experiment or any machine that available is the open system or control volume. In this control volume, the mass is no longer fixed. The mass and energy can cross across the system. The system here, for example, if you look at this diagram, an example of the system of control volume, it's almost the same like closed system or control mass with the moving boundary, and then with the fixed boundary. However, you will see there is something new here. This is inlet, where we can insert mass, for example like gas. So we can insert mass of gas into the system. So for the water bottle in the closed system or control mass, the water just stay there. Although let's say we heat up the bottle, the mass of the water in the bottle still remain the same, although the volume might be slightly increased or decrease. In the control volume, we open the lid of the bottle and then we put the bottle to the horizontal position, and the water from the bottle we pour out from the bottle. The mass of the water in the bottle will be decreased, and then what will happen to the mass of the water? The mass of the water in the bottle will decrease, but the mass cannot be destroyed. The mass of the water in the bottle was fully out, which exactly the same mass value of the water in the bottle. I will explain to you in details later in the video part 3 in the continuity equation. So how can we set up our control volume? Selecting a proper control volume is very important. As I showed you earlier, every system has real boundaries. However, in the control volume, we require to set imaginary boundaries that consider the presence of the mass coming in and out from the system. We do have, for example, these two cylinders that connected in the middle, and then they have flow coming in. When I say flow, definitely flow must have mass. Okay, so whenever the mass coming in and out from left to the right, you will see that the mass from cylinder 1, this one is cylinder 2, so the mass from cylinder 1 go to the cylinder 2 and then exit from the cylinder 2. Okay, so basically having this, you know that this is not closed system or control mass, because the mass can come in and go out from the system. Then to set up the control volume, we need to have imaginary. So we know that we do have real boundary condition and imaginary boundary condition. So our real boundary condition, definitely the surfaces here, right? The blue color, the surfaces. But we want to have imaginary boundary. So usually students or even scientists can mistakenly set up wrong analysis because of the wrong control volume selection. So let's see what usually the wrong control volume that been selected. This is the wrong control volume selection. You will see the dot red color here is wrong. Why it is wrong? Firstly, you will see it's cover the whole part and combine both cylinder. This is wrong because, you know, in this area there is no system at all, right? The real boundary separated both cylinder. This is system 1, this is system 2, control volume 1, control volume 2, right? So this is wrong. So what could be the correct control volume? This is control volume 1. You'll see control volume 1, they put nicely the imaginary control volume in the cylinder 1 and then in the cylinder 2. Having this accurate or correct imaginary control volume is very important, especially when you deal with a few inlets and a few outlets. You have to carefully check what is the mass that coming to the system, what are the mass that go out from the system. Second, if you do have that different system, you have to make sure that the system is properly bounded, imaginary boundary condition. So this control volume is very important. We will use this control volume throughout the study of fluid in motion, and then in the part 3 video I will show you how can we utilize control volume in the continuity equation where the mass has to be conserved. Definitely, if mass has to be conserved, we have to know where the mass come in, what is the mass flow rate that come into the system, and what is the mass flow rate that go out from the system. And definitely control volume is useful in many applications like turbine, compressor, nozzle, even the pipe, that we can use it to calculate the pressure field and the velocity field. For example, like this simple pipe, right? We want to know what is the velocity here, what is the P here, and also what is the velocity here, what is the P here. Name it P1, V1, P1, V2, P2. I will explain in detail definitely later in the video part 3. Thank you.